Hello, this is Mr. Bowen here with another mathematical video. Today we're going to be discussing whether or not a collection of coordinates gives us a right triangle in the two-dimensional Euclidean plane. Alright, so in this specific example, we're going to be reviewing whether or not the triangle formed by the connection of these points, t, r, and I, at 3, 3, -5, 6, and -11, -10, gives us a right triangle. Before we get started, I just want to make some definitions clear. All right. First off, what is a right triangle? Well, a right triangle is any triangle with a right angle of 90 degrees. Okay. Second, what does it mean for this angle to be right? Well, in other words, we could say that a triangle that has a right triangle is a triangle that has a pair of perpendicular sides. All right. All right, we're going to need one last piece of information in order to determine whether or not our sides are perpendicular, okay? And that's going to be this statement right here. Two segments are perpendicular. Let's write this down. Two segments are perpendicular if their slopes are negative reciprocals of each other. And we're going to go over that means in just a moment. Are negative reciprocals of each other. In other words, the product of the two slopes, if the product of the two slopes is -1, then they're perpendicular. So if product of slopes, product meaning multiplication, of course, product of slopes is -1, then they're perpendicular. All right. So how are we going to tackle this problem now, given this information here and our information up here? Well, let's go to the plane. Let's go take a look at the Euclidean plane. All right. And we're going to label these off as 5. So this is 5, 0, this is 10, 0, this is 0, 5, 0, 10, etc. Let's plot our triangle, or let's plot the points and see if we even have a triangle first off. First, point T was 3, 3, which is here. Point R is -5, 6, so -5, 6, that's up here. And point I was -11, -10, so let's see, -10, or -11, and -10, which is right around here. All right. Do we have a triangle? Well, it certainly looks that way. Let's see what we got. Boom. And good. And good. So we definitely have a triangle here. Now the question is it a right triangle? Is this right? All right. Looking at it here, we could say that maybe this angle here could be right, and maybe this one doesn't look that right, but maybe I didn't draw it properly. This could be a right angle. Who knows if maybe my drawing's off a little bit. This down here definitely doesn't look like one, but we'll see. All right? We'll see. We don't know. We have to figure this out mathematically. We have to show this mathematically. All right. How are we going to determine whether or not this is a right triangle? What do we know? We know that this point here is 3, 3. We know that this point here is -5, 6. And we know that this down here, this is -11, -10. We know that if any of the slopes are the negative reciprocals of each other, then we have a right triangle. Okay? That is, the product of the slopes equals -1. We have a right triangle. How are we going to determine what the slopes are, though? Do I remember the formula for slope? How many slopes do we have? Well, slope is something that goes along with a line. So I definitely have a line here. I have a line here, and I have a line here. So we have 3 lines. Must mean we have 3 slopes. Okay. What's the formula for slope? I remember. M's this letter that they keep using for slope for some reason. M is equal to y1 minus y2 over x1 minus x2. Okay. How do I determine what my y1 and my y2 are? Well, I just have to make sure I keep it consistent from each value to each value. So for example, I have 3, 3 here and negative 5 comma 6 here. So y1 could be 3 coming from here. y2 could be 6 minus 6. All right, put that over x1. Well, that has to be 3 minus x sub 2, which is negative 5. And I'm subtracting negative 5. So I'm just going to change that to addition. All right, so the slope for this line here is going to be equal to this, and 3 minus 6, what is that again? That's negative 3. And 3 plus 5 is 8. So it looks like we have here a slope of negative 3 over 8. Hey, actually, I know a trick. If I have such nice points here, I could actually count the rise over the run. I actually have here I have a fall over run because I have a negative slope, but 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. That's another way I could have determined what this slope is here. Okay. So, the rise over run here, or the fall over the run, is negative 3 over 8. The slope here is negative 3 over 8. That's one piece of information that's important. Let's call this m sub 1. All right? M sub 1, the slope of this line here, which I will call m sub 1, is negative 3 over 8. What next? Well, I need to determine what the slope here is, and I need to determine what the slope here is. I could count, or I could use the formula. I prefer the formula. Formula seems a little easier, especially seeing how long this is. Okay? So, let's call this m sub 2. And we're going to say m sub 2 is equal to, well, 3 minus negative 10, make that addition, over 3 minus negative 11. Make that addition again. So this is 13 over 14. All right, so m2 is 13 over 14. Very good. The slope here is 13 over 14. Last, I need to find the slope from here to here. All right, we'll call this m sub 3. Well, let's just count this one. All right, how far are we going to fall? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. And then 1, 2, well, let's start down here. 1, 2, 3, 4, 5, 6. 6. All right. This is a positive slope, so this is 16 over 6. That simplifies to what? 8 over 3? Hey, that 8 over 3 looks pretty familiar, actually. All right. So at this point, we've determined all 3 of the slopes. I want you to tell me whether or not we have a perpendicularity here, whether or not we have a right triangle, and why. All right? Tell me which of the slopes help you determine that and why. And what definition is it that we're using in order to determine it. Okay? I hope you all have a great day. Thank you very much.